You've never once felt yourself move. You sit quietly in your chair, feeling the solid ground beneath you, completely convinced that you are perfectly still. You trust your senses, but that comforting stillness is a lie. Right now, you are being violently hurled through the cosmos. Our entire world is caught in a terrifying cosmic tug-of-war, dragged across a boundless void by invisible, colossal forces. We're tumbling through a staggering emptiness, rushing headlong into the dark without feeling a single tremor. The universe is not a quiet, crowded neighborhood holding us tight. It is an immense, desolate ocean, and we are helplessly adrift in its deepest, coldest waters, completely surrounded by a terrifying void. Today you'll find out what the cosmos really is, and why its terrifying emptiness is the exact reason you exist. For a very long time, humanity believed that space was just a quiet, passive backdrop, holding the stars together in a gentle embrace. But the truth is far more extreme and much more unsettling. The colossal voids stretching between galaxy clusters are not truly empty, and they are definitely not silent. They are violent, active forces shaping the destiny of the entire universe, violently pushing and pulling immense galaxies across unimaginable distances. Every single atom in your body and everything you will ever be is intimately tied to this chilling, invisible nothingness. If you love wandering through the night sky, subscribe to the channel. That's what keeps this work going. Before we set off, one question for you. Where in the world are you watching the sky from, and what time is it where you are? Tell us in the comments. Let's step into the dark. To understand this terrifying cosmic void, we first have to look at the comfortable illusion humanity clung to for centuries. For most of our history, the very idea of absolute emptiness was considered a physical impossibility. The human mind simply could not accept the existence of a true vacuum. We desperately needed to believe that we were wrapped in a protective, continuous fabric of matter. This deep psychological need shaped all of early science and philosophy. In the 11th century, the brilliant polymath Ibn Sina wrote his famous Book of Healing, launching a direct, fierce attack on the concept of a void. He argued passionately that movement itself required a physical medium, insisting that the entire universe had to be completely filled with a dense, invisible substance called the ether. He posed a haunting question. If a man were floating perfectly alone in the absolute dark without light or surrounding matter, how could he even exist? For Ibn Sina, and for the thinkers who followed him, the answer was simple. The void could not exist. If you were floating in the darkest corner of the sky, you were never truly alone. The cosmos was physically touching you, holding you tight. For hundreds of years, this comforting blanket became the reigning scientific dogma. Astronomers looked up at the night sky and saw a densely packed, secure neighborhood. By the late 19th century, the global scientific community firmly believed that the Milky Way was the entire universe. It was a static, quiet, and intimately crowded place. Everything was solved. We knew our exact place, and we felt perfectly secure in our bright, bustling cosmic city. But in 1929, that comforting historical illusion violently shattered. At the Mount Wilson Observatory in California, the astronomer Edwin Hubble spent night after freezing night staring through the massive 100-inch Hooker telescope, relentlessly analyzing the faint light of distant spiral nebulae. At the time, the astronomical community was locked in a bitter conflict known as the Great Debate. Many prominent scientists passionately insisted these glowing clouds were just small, local star-forming regions right here inside our own galaxy. Hubble completely destroyed that arrogant assumption. By meticulously measuring the redshift of their light, he proved that these nebulae were entirely separate, massive galaxies, located millions of light-years away from us. The universe was not just the Milky Way. It was unimaginably immense, and it was violently expanding. Suddenly, the safe, crowded neighborhood dissolved into a terrifyingly vast, dark ocean. Humanity realized that the gaps between these island universes were overwhelmingly huge. The spaces between galaxies were no longer minor gaps. They were monstrous chasms of nothingness. The protective blanket of the ether was ripped away forever, leaving us completely exposed. Yet, even after Hubble drastically expanded the borders of reality, astronomers still desperately clung to a modified version of the old dogma. They could not let go of the idea of cosmic harmony. They assumed that whatever matter existed in this vast new universe was spread out somewhat evenly. They strongly believed that if you looked at a large enough slice of the sky, you would find a smooth, perfectly predictable distribution of galaxies. The cosmos might be huge, but it was supposedly fair, uniform, and entirely filled with shining matter. It was a mathematical comfort. In 1933, the eccentric Swiss astronomer Fritz Zwicky drove the next massive crack into this fragile certainty. Zwicky aimed his instruments at the Coma galaxy cluster, a massive, brilliant grouping of galaxies bound together by gravity. He meticulously measured the speeds at which these individual galaxies were orbiting the center of the cluster. The results made absolutely no sense. The galaxies are moving so incredibly fast that the visible mass of the cluster cannot possibly hold them together. According to the strict laws of Newton and Einstein, the Coma cluster should tear itself apart, flinging its incredibly fast galaxies into the dark void like shrapnel. Zwicky realizes there is only one logical explanation. He boldly proposes the existence of dark matter, an invisible, unknown mass that provides the massive extra gravity needed to keep the cluster intact. He explicitly suggests that the universe is completely dominated by something we cannot see, touch, or interact with. The scientific community reacts with fierce, immediate denial. They mock his findings. They aggressively ignore his equations. The dogma fights back, refusing to accept that the visible stars and galaxies are just a tiny, insignificant fraction of reality. Zwicky spends years fighting a bitter, lonely battle, shouting into a scientific void that stubbornly refuses to listen. The world was simply not ready for an invisible universe. The ultimate crisis, however, arrives decades later, in 1981. A team of ambitious astronomers, Robert Kirshner, Augustus Umler, Paul Schechter, and Stephen Schechtman, set out to create a comprehensive three-dimensional map of the universe. They decide to survey 3 specific small slices of the deep sky, carefully measuring the distances to various galaxies to see exactly how they are distributed. Based on the globally accepted models of a uniform, well-behaved universe, they calculate exactly what they should find. In a volume of space that large, basic statistical averages dictate that they must find approximately 2,000 galaxies. It is simple, undeniable math. The universe is supposed to be evenly populated everywhere you look. They collect the faint light. They feed the numbers into their computers. They expect to see a crowded, bustling map of galactic superclusters lighting up their screens. But the results come back, and they are utterly shocking. In that massive, staggering expanse of deep space, they do not find 2,000 galaxies. They find roughly 60. The team stops breathing. They stare at the glowing screens in pure disbelief. They immediately assume their instruments are broken. They furiously check the telescope calibration, verify the software code line by line, and recalculate the redshift data from scratch. They desperately try to find the missing galaxies, but the data remains stubbornly, terrifyingly clear. There is no mathematical mistake. There is no equipment failure. They have stumbled upon the Boötes Void, a spherical region of dead space 330 million light-years across that is almost entirely empty. It is a hole in the universe so impossibly large that if the Milky Way had been placed dead in its center, humanity would not have known other galaxies even existed until the 1960s. We would have thought we were entirely alone in existence. The universe is not a smooth ocean of matter. It is a spongy, grotesque web completely dominated by colossal dead zones where nothing grows, nothing shines, and absolutely nothing exists. The cozy illusion of a full cosmos is finally dead. Oh, we're living on the jagged edge of unimaginable dark abysses. And this is where the logic falls apart. That terrifying revelation only makes sense once you understand what is physically tearing these cosmic structures apart. For decades following the discovery of the Boötes Void and the shocking realization of dark matter, scientists struggled to understand the underlying mechanics of this grotesque, sponge-like cosmos. If the universe was dominated by immense dead zones and bound by invisible mass, what was its ultimate fate? Gravity is an attractive force. The combined gravitational pull of all the galaxies, all the dark matter, and all the stray gas should act like a giant set of brakes on the universe's expansion. Everyone assumed that the initial explosive momentum of the Big Bang was gradually running out of steam. The only real debate was whether gravity would eventually win completely, halting the expansion and pulling everything back into a catastrophic big crunch, or if the expansion would just coast to a painfully slow, gradual halt. To settle this massive question, astronomers needed a cosmic measuring tape. They needed a way to measure exact distances across the deepest, darkest trenches of space to see exactly how the expansion rate was changing over time. To do this, they turned to one of the most violent and spectacular phenomena in nature, the Type Ia supernova. Imagine the physical setup of this extraordinary cosmic mechanism. Picture a binary star system, two stars locked in a deadly gravitational waltz. One of them is a white dwarf, the incredibly dense, dead core of a former star. It is roughly the size of the Earth, but it contains the crushing mass of our entire Sun. Its gravity is ferociously strong. The other star is a bloated, aging giant shedding its outer layers. As they furiously orbit each other, the white dwarf acts like a relentless cosmic parasite. It ruthlessly siphons a steady, glowing stream of superheated plasma from its larger, dying companion. This stolen gas spirals downward in a brilliant accretion disk, crashing onto the incredibly dense surface of the white dwarf, piling up layer by heavy layer, relentlessly increasing the dead star's mass, internal temperature, and crushing pressure. But there is a strict mathematical limit to how much a white dwarf can take, known as the Chandrasekhar limit. The moment the white dwarf reaches exactly 4 times the mass of our Sun, its internal structure can no longer support its own weight. In a fraction of a second, a runaway thermonuclear fusion reaction ignites in its core. The star detonates, completely obliterating itself in a flash of light so intensely brilliant that it can easily outshine its entire host galaxy. And because this catastrophic explosion is triggered at an exact unvarying mass limit, every single Type Ia supernova across the universe detonates with the exact same absolute luminosity. They are perfect standard candles. If you see one look incredibly dim in your telescope, you know it is not a small explosion, it is just extremely far away. By carefully measuring that apparent brightness, you can calculate the exact distance to that dead star with phenomenal precision. In 1998, 2 fiercely competitive teams of astronomers went to war over these dying stars, the Supernova Cosmology Project and the High Z Supernova Search Team. Their goal was monumental yet straightforward. They wanted to find distant supernovae, measure their exact distances and compare them to the redshift of their galaxies. By doing this, they could chart the historical expansion of the universe and finally prove how much the cosmos was slowing down. It was grueling, exhaustive work that pushed both the astronomers and their equipment to the absolute limit. Astronomers spent countless frigid, sleepless nights in the cramped, isolated control rooms of the world's most massive telescopes, perched on the high, thin-air peaks of the Chilean Andes and the dormant volcanoes of Hawaii. They relentlessly scanned tiny, seemingly empty patches of the deep sky. They used newly developed, highly sensitive digital, charge-coupled devices to capture the impossibly faint photons arriving from the very edge of the observable universe. The process was agonizingly slow. They would take a picture of a galaxy field, wait 3 weeks, and take another picture of the exact same field. Then, computers would subtract the first image from the second. If a tiny pixel of light remained, it meant a star had violently ended its life in the intervening weeks. It was an elegant, brutal search for cosmic death. As the data from these distant explosions began to pour in, both teams sat in their respective laboratories, running the calculations. They expected the supernovae to be relatively bright, proving that the universe's expansion was decelerating, allowing the light to cross the distance faster than if the expansion were constant. But the numbers completely defied their expectations. The distant supernovae were much dimmer than they were supposed to be. They were significantly farther away than the deceleration models allowed. At first, both teams assumed they had made a disastrous error. They checked for interstellar dust blocking the light. They checked their software. They checked their mathematical models. But the two bitter rivals, using different data sets and different software, arrived at the exact same impossible conclusion. The universe was not slowing down, it was accelerating. The space between galaxies was not just drifting apart from the initial kick of the Big Bang. A mysterious repulsive force was actively stretching it, driving the fabric of space outward and gaining strength every single second. This was the moment the crisis was resolved, but the resolution was utterly terrifying. This acceleration explained why the cosmic voids like Boötes were so massive and dominant. The empty space was not just passive nothingness, it was aggressively pushing the matter away, hollowing out the universe from the inside. The voids were winning. This shocking revelation forced the global scientific community to resurrect a deeply controversial idea that Albert Einstein had angrily buried over 80 years earlier. Back in 1917, when Einstein first applied his beautiful, groundbreaking general theory of relativity to the entire cosmos, his raw equations suggested that the universe could not sit still. It must either be violently collapsing under its own weight or rapidly expanding. Because the reigning scientific dogma of the time demanded a perfectly static, eternal and unchanging universe, Einstein felt compelled to artificially add a mathematical fudge factor to his equations, the cosmological constant represented by the Greek letter lambda. It was a repulsive force designed to exactly balance out gravity and keep the universe still. When Edwin Hubble proved the universe was expanding in 1929, Einstein famously retracted the cosmological constant, calling it the biggest blunder of his professional life. But in 1998, the accelerating universe proved that Einstein's blunder was his most profound unintended prophecy. The cosmological constant was absolutely real, but it wasn't keeping the universe static. It was tearing it apart. This repulsive energy of empty space was suddenly given a new ominous name: dark energy. Scientists realized that the absolute vacuum of space is not a dead, empty stage. It has an intrinsic, restless energy of its own. So, as the universe expands, there is more empty space, which means there is more dark energy, which pushes the universe to expand even faster, creating an unstoppable, devastating feedback loop. The nothingness was alive, and it was violently hostile to the existence of matter, but the confirmation raised an even more troubling puzzle. But how does this terrifying emptiness actually work? Let's take it apart. The discovery of dark energy and the accelerating expansion of the universe left us with a chilling realization: the vacuum of space is not a passive, empty stage waiting for things to happen. It is an active, aggressive player in the evolution of the cosmos. To truly understand how this relentless expansion shapes our physical reality, we have to zoom out significantly. We have to stop looking at the universe as a scattered collection of isolated stars and planets and start looking at it as a single, staggering piece of anatomy. Imagine boarding a spacecraft capable of moving millions of times faster than the speed of light. You travel far beyond the borders of our Milky Way, far beyond the Andromeda galaxy, and far beyond our entire local group. As you look back, the individual shapes of spiral and elliptical galaxies begin to blur together. At this colossal scale, they do not form a random, chaotic cloud of matter, as early astronomers once assumed. So instead, they organize into a breathtaking, incredibly intricate structure known to astrophysicists as the cosmic web. To visualize this mind-bending structure, think of it like looking down at the Earth from orbit on a clear, dark night. When you look at the nighttime surface of our planet, you see massive, blindingly bright metropolitan cities. These cities are intensely crowded, buzzing with energy, and they are connected to one another by thin glowing highways. But stretching between those cities and highways are immense pitch-black deserts, oceans and frozen tundras where absolutely nobody lives. The universe is structured in exactly the same way, but on a terrifyingly massive three-dimensional scale. In this cosmic architecture, the cities are galactic superclusters. These are the most massive gravitational nodes in existence, containing thousands upon thousands of galaxies violently smashing into one another in a slow-motion cosmic dance. The highways connecting them are colossal cosmic filaments, long twisting threads of dark matter, glowing intergalactic gas, and stardust that stretch for hundreds of millions of light years. These filaments act as gravitational rivers, constantly feeding raw matter down into the superclusters. And the deserts? Those are the cosmic voids. For a very long time, scientists thought these voids were simply boring, passive gaps in the architecture of the cosmos. They were considered places where gravity just failed to pull enough matter together, leaving behind an uninteresting patch of nothingness. We now know that this assumption is completely wrong. Cosmic voids are not just empty space, they are incredibly dynamic, powerful structures that dictate the shape of everything else. They make up roughly 80% of the entire volume of the observable universe. They are the true dominant feature of reality. Inside a void, the density of matter drops to almost zero. Because there is virtually no mass inside them, there is almost no gravity to hold them together or slow them down. This means that they are entirely at the mercy of dark energy. As dark energy aggressively stretches the fabric of space, the voids act like rapidly inflating balloons in a confined space. They actively push outward. From the perspective of the matter trapped in the filaments, these voids act as immense repulsive forces, relentlessly sweeping stray galaxies away from their centers and crushing them into the dense glowing walls at their edges. The cosmic web is not just sitting statically in the dark, it is a violent, ongoing war between the gravity of the filaments, desperately pulling matter in, and the dark energy of the voids violently pushing it away. To truly grasp the horrifying scale of this anatomy, we must look at the undisputed king of all empty spaces, the Boötes Void. Located in the northern constellation of Boötes, this spherical region of deep space is a staggering 330 million light-years in diameter. It is so incomprehensibly massive that it fundamentally defies our basic mathematical understanding of how the universe formed. According to standard cosmological models, there simply hasn't been enough time since the Big Bang for a hole this massive to naturally clear itself out through normal gravitational processes. To solve this terrifying anomaly, scientists suggest that the Boötes Void might be a megastructure created when several smaller voids slammed together and merged over billions of years, much like small soap bubbles merging to form one massive, terrifyingly fragile dome. To put its sheer size into perspective, the Milky Way galaxy, which contains hundreds of billions of stars and takes light 100,000 years to cross, is just a tiny speck in comparison. You could fit over 3,000 Milky Way galaxies side by side straight across the diameter of the Boötes Void. If you were somehow teleported to a planet orbiting a lone star dead in the center of the Boötes Void, your physical and psychological experience of the universe would be profoundly, terrifyingly different. When you looked up at the night sky, you would not see a brilliant river of stars crossing the heavens. You would not see neighboring galaxies glowing faintly in the distance. You would see absolutely nothing. You would be trapped under a pitch-black, suffocating dome of pure darkness. The nearest neighboring galaxy would be so unimaginably far away that its light would be far too faint for the human eye to detect. So, if humanity had evolved in the center of the Boötes Void, our astronomers would have had no idea that other galaxies existed. We would have assumed, well into the mid-20th century when our telescopes finally became powerful enough, that our single, lonely galaxy was the only thing that existed in the entire universe. The Boötes Void is the physical manifestation of absolute cosmic isolation. However, these voids are not 100% empty. Deep within these terrifying oceans of nothingness, isolated from the chaotic traffic of the superclusters, exist the rarest objects in the universe, void galaxies. These lonely galaxies are the ultimate introverts of the cosmos. Because they are trapped inside a rapidly expanding void, they are constantly being pushed further and further apart from one another. They never collide. They never interact. They just sit perfectly undisturbed in the dark, pristine and completely alone. Studying them gives us a chilling look at what happens when a galaxy is left to survive in the absolute harshest, most desolate environment physics will allow. Yet, there is a dark, terrible beauty to this entire structure. The cosmic web, with its bustling superclusters, delicate filaments, and terrifying voids, is the largest, most complex physical object in existence. It is a delicate, shivering masterpiece of gravity and dark energy, perfectly balancing on the edge of oblivion. We exist only because we are safely tucked away in one of its dense, glowing filaments, heavily protected from the crushing, isolated emptiness of the deep voids by the gravity of our local neighborhood. But this delicate balance is not permanent. What happens when the voids finally win? That terrifying victory only makes sense once you understand the invisible cage holding the galaxies together. When we look at a stunning high-resolution photograph of a spiral galaxy like our own Milky Way, or the Andromeda galaxy next door, we naturally assume we are seeing the entire structure. We look at the brilliant, glowing core, the sweeping, elegant spiral arms, and the billions of burning stars, and we think that is all there is. We strongly believe we are looking at the complete object. But the truth is profoundly different and deeply melancholic. The vibrant, glowing galaxy that we can easily see with our telescopes is nothing more than a tiny, fragile ornament. It is suspended dead in the absolute center of a colossal, completely invisible prison. This unseen structure is known to astrophysicists as the dark matter halo, and it fundamentally dictates the entire life and the inevitable death of every single galaxy in the cosmos. To understand the immense weight and the suffocating reality of this invisible cage, we have to look closely at the mathematics that explicitly define it. In the late 1990s, three brilliant scientists, Julio Navarro, Carlos Frenk and Simon White, developed a groundbreaking mathematical model, now universally referred to as the NFW profile. They ran massive, highly complex supercomputer simulations to understand exactly how dark matter would behave under the strict influence of its own gravity over billions of years. Their equations described perfectly how this invisible mass is distributed throughout the universe. It revealed a chilling, inescapable reality. Dark matter does not just float randomly in space like a gentle, diffuse mist. It organizes itself into massive, crushingly dense spheres of intense gravity. According to the NFW profile, the dark matter halo is incredibly dense at its absolute center, precisely where the visible galaxy resides, and its density slowly, gradually tapers off as you move further outward into deep space. This means that our bright, beautiful Milky Way is completely submerged in a heavy, suffocating ocean of invisible mass. This dark halo extends for hundreds of thousands of light years beyond the very furthest visible stars of our galaxy. It is staggeringly massive. The visible stars, planets, and gas clouds make up less than 10% of our galaxy's total mass. The other 90% is this heavy, ghostly cage. If you could put on a pair of magic glasses that allowed you to see dark matter, the night sky would fundamentally, terrifyingly change. The delicate glowing spirals of the galaxies would completely vanish from prominence, swallowed up by massive, terrifyingly huge, perfectly spherical blobs of dark, heavy gravity. You would see that the Milky Way and Andromeda are just two tiny glowing cores buried deep within an unimaginably vast shared ocean of invisible mass. These massive spheres are all connected by the thick invisible threads of the cosmic filaments, forming the heavy hidden skeleton of the entire universe. There is a profound, crushing sadness in this realization. The dark matter halo is the absolute only reason we exist. Without its immense, unseen gravitational grip, the fast-moving stars in our galaxy would fly apart, scattered helplessly like dust into the freezing empty depths of the cosmic voids. The halo aggressively holds us together. It violently protects us from being ripped apart by our own rotational speed. But this vital, necessary protection comes at a deeply melancholic price. We are entirely trapped within it. We are permanent prisoners of our own survival, locked in a heavy cage we can neither see nor escape. As dark energy relentlessly fuels the aggressive expansion of the cosmic voids, the delicate filaments of the cosmic web are being violently stretched. They are being pulled thinner and thinner by the repulsive force of the growing empty spaces. The galaxies trapped inside their heavy dark matter halos are like desperate survivors huddled on tiny isolated islands in the middle of a rising, relentlessly hostile ocean. Right now, in the present cosmic epoch, our island is still connected to other islands via the cosmic filaments. We can still see our galactic neighbours. We can still feel the gravitational pull of the immense Virgo supercluster, drawing us towards a massive congregation of thousands of other galaxies. We are part of a larger community, a bustling cosmic metropolis of shared light and gravity. But this era of cosmic connection is slowly, tragically, coming to an end. Over the next several billion years, as the cosmic voids continue to forcefully inflate and push everything apart, the fragile filaments connecting the superclusters will inevitably snap. The vast stretching distances between these heavy dark matter islands will become utterly insurmountable. The relentless pushing force of dark energy will completely overpower the gravitational bonds of the larger cosmic web. When that happens, the galaxies will become completely, permanently isolated. The heavy dark matter halos will keep the individual local groups of galaxies intact, but they cannot save them from the encroaching, terrifying nothingness. They will be entirely cut off from the rest of the universe. Because the immense voids are actively isolating every single galactic cluster, no new hydrogen gas will ever arrive from the outside to fuel the birth of new stars. The cosmic supply chain will be permanently severed. Inside this invisible, heavy cage, the billions of burning stars will eventually inevitably run through their nuclear fuel. They will violently detonate as supernovas or quietly shrink into fading white dwarfs. But because there is no new gas flowing into the halo from the cosmic web, no new stars will be born to replace the ones that die. The galaxy will slowly, quietly begin to starve. The dark matter halo, which once protected the vibrant galaxy and held it together, will slowly transform into a heavy, invisible tomb. The brilliant, swirling galaxies will slowly grow cold and dark, locked forever inside their heavy, invisible shrouds. As the billions of years drag on, the night sky will gradually empty out. The distant galaxies will fade beyond the cosmic horizon, leaving our local group completely alone in the endless dark. The vibrant, intimately connected cosmic web that we are so incredibly lucky to witness today is not a permanent, stable fixture of physical reality. It is just a temporary, fleeting moment of the light and structure in a universe that is mathematically destined for an eternal, heavy darkness. We are living in a brief, beautiful twilight. The immense dark matter cage holding us together is precisely the thing that will silently carry us into the long, suffocating cosmic night, preserving our dead stars in a perfect graveyard. And this is exactly where the real nightmare begins. But how does this final boundary actually work? Let's take it apart. The nightmare of our heavy, isolating dark matter cage is only a small local fraction of the true cosmic terror. To fully grasp the sheer scale of our insignificance, we have to look past our own galaxy, past the immense Virgo supercluster, and past the colossal Boötes Void. We have to stare directly at the absolute mathematical limit of human perception, the boundary of the observable universe. When astrophysicists talk about the universe in their mathematical models and theories, they are usually only referring to a specific finite bubble of space that we can observe. This bubble extends approximately 46 billion light-years in every single direction from our tiny planet Earth. We desperately treat this immense spherical volume as if it is the entirety of existence itself, but it is not a physical solid wall. It is merely a horizon of time and light. It is an arbitrary limit imposed by our tiny position in space. Because the universe is roughly 13.8 billion years old, and light travels at a strict, finite speed, we can only see the objects whose light has had enough time to physically reach our telescopes. Everything beyond that boundary is completely permanently invisible to us. But the universe does not stop there. It continues, vast, cold, dark, and filled with the exact same repeating pattern of massive voids and glowing filaments stretching out for perhaps an infinite distance. We are trapped exactly in the center of our own personal shrinking bubble of reality, and it is shrinking. Because dark energy is aggressively accelerating the expansion of the cosmos, the empty space between us and the furthest galaxies is multiplying at a terrifying rate. At the very edges of the observable universe, the sheer amount of expanding space between us and those distant objects means they are receding from us much faster than the speed of light. As they cross this invisible mathematical threshold, their light will never, ever be able to cross the expanding gap to reach us. Every single second of every day, countless entire galaxies silently slip over the cosmic horizon and vanish into the unobservable dark forever. No matter how powerful our technology becomes, no matter how many millions of years humanity manages to survive and build larger telescopes, we will never, ever see those lost galaxies again. They are gone forever. The finite universe we are physically allowed to interact with is constantly losing mass, fading away into a permanent, untouchable blackness. We are profoundly, hopelessly small, standing completely helpless on a tiny fragile rock as the rest of creation rushes away from us into absolute oblivion. But where did this terrifying, escaping structure truly come from? Why is the universe organized into this grotesque, stretching web of matter and dominant, empty voids in the first place? To find the origin of the absolute largest, most horrifying structures in existence, we have to look at the absolute smallest. We have to look at the microscopic, terrifying nothingness that existed at the very beginning of time. In the first trillionth of a trillionth of a trillionth of a second following the Big Bang, the universe went through an unimaginably violent, rapid phase of expansion known as cosmic inflation. Right before this cataclysmic event, the entire universe was microscopic. It was vastly smaller than a single proton. And in that infinitely tiny, incredibly dense state, the comfortable laws of classical physics did not apply. The universe was ruled entirely by the bizarre, unpredictable, and chaotic laws of quantum mechanics. At the subatomic level, the vacuum of space is never perfectly empty. It is a boiling, chaotic sea where pairs of virtual particles are constantly, violently popping in and out of existence, borrowing energy from the void and returning it a microsecond later. These tiny, completely random bursts of energy create microscopic variations in density, known to physicists as quantum fluctuations. They are the background noise of nothingness. When cosmic inflation hit, it grabbed that microscopic boiling patch of quantum space and instantly stretched it to macroscopic cosmic proportions. It happened so fast that those tiny random ripples in the vacuum were permanently frozen into the fabric of the expanding universe. The microscopic areas that were slightly denser became the heavy gravitational seeds that would eventually pull matter together to form the heavy dark matter halos, the superclusters, and the brilliant filaments of the cosmic web. The microscopic areas that were slightly emptier were violently stretched into the colossal, terrifying expanses of the cosmic voids. This means that the grand structure of the universe is nothing more than a physical monument to microscopic chaos. When you look up at the night sky, and you truly comprehend the staggering 330 million light-year expanse of the massive Boötes Void, you're not just looking at cold, empty space. You're looking directly at a heavily magnified, permanently frozen photograph of subatomic nothingness. The grand, sweeping architecture of the cosmos, the very heavy cage that completely dictates our survival and our eventual permanent isolation, is simply a magnified quantum error. We are not the grand, intended observers of a carefully designed, purposeful universe. We are microscopic, fragile bacteria crawling around inside a frozen random fluctuation of nothingness. The exact same empty, chaotic void that exists between the distant stars also exists inside the atoms of your own body, making up the vast majority of your physical form. We are surrounded by it, we are built entirely from it, and we are utterly powerless against its mechanical laws. The sheer, overwhelming scale of the cosmos is not a testament to human importance, it is a mathematical guarantee of our absolute crushing insignificance. We are just a temporary fading biological anomaly in a universe that is fundamentally empty, heavily structured by ancient microscopic noise, and rapidly, aggressively tearing itself apart. But this terrifying origin story only confirms one inescapable conclusion. To understand this inescapable conclusion, we first have to look at the absolute absurdity of the cosmic inventory. When you look up at the night sky, you intuitively assume that the glowing stars, the swirling gas clouds, and the solid planets make up the vast majority of reality. You naturally feel like solid matter is the default state of the universe. But if we were to take everything that exists within the massive observable boundaries of the cosmos and place it on a hypothetical scale, we would find a profoundly disturbing, deeply humbling truth. Astrophysicists heavily rely on this measurement, calling it the cosmic energy budget, and it reveals that we are simply ghosts in our own house. Everything that we consider normal matter, every single star, every black hole, every bright nebula, every grain of sand, and every human being that has ever lived, makes up barely 5% of the entire universe. That is all we are. 5%. Think about the sheer arrogance of human history, assuming that the cosmos was built primarily for our benefit, when the very material we are constructed from is little more than a rare, exotic impurity in the grand cosmic scheme. We are just a mathematical rounding error in the universe's master ledger. The visible universe is nothing but a thin layer of frost on a massive dark window. So, what is the rest of reality truly made of? 27% of the universe is dark matter, the heavy invisible cage that dictates the overarching structure of the cosmic web and physically holds our spinning galaxies together. And a staggering, overwhelming 68% of the universe is dark energy, the repulsive, invisible force inherent to the vacuum of space itself. The vast, overwhelming majority of physical reality is fundamentally made of nothingness. The universe is fundamentally a silent, invisible war zone between two opposing, deeply mysterious forces. On one side, we have dark matter. Dark matter acts as the ultimate cosmic builder, or it uses its intense, invisible gravitational pull to desperately drag stray hydrogen gas together, construct massive galactic superclusters, ignite the very first stars, and weave the heavy, protective halos that allow biological life to eventually evolve. Without the aggressive, pulling force of dark matter, the fast-moving gas of the early universe would have simply drifted apart into the void, and we would absolutely not be here today. On the opposing side, we have dark energy. Dark energy acts as the ultimate cosmic destroyer. It is a repulsive, negative pressure that naturally constantly exists within the empty vacuum of space itself. It does not pull, it aggressively pushes. It is constantly, relentlessly trying to stretch the fabric of the universe apart, aggressively expanding the massive cosmic voids, and desperately trying to isolate every single physical structure in existence. The greatest contradiction of everything lies exactly here. We exist solely because these two colossal, completely invisible forces are currently locked in a brutal, universe-spanning tug-of-war. Gravity is desperately trying to crush everything together, and dark energy is violently trying to rip everything apart. We live entirely in the crossfire, but the true underlying paradox is not just that these two colossal forces are fighting. The real horror lies in their exact mathematical values. When theoretical physicists look closely at the microscopic boiling chaos of quantum mechanics, they can mathematically calculate exactly how much intrinsic energy the vacuum of space should contain. This theoretical value is deeply tied to Albert Einstein's famous cosmological constant. According to the strict, highly successful laws of quantum field theory, the fundamental energy of empty space should be incredibly, overwhelmingly massive. But when astronomers physically look through their massive telescopes and carefully measure the real physical expansion rate of the universe, they get a wildly different number. The actual measured strength of dark energy is incredibly weak compared to the theoretical quantum prediction. The difference between the mathematics of quantum mechanics and the physical reality measured by our telescopes is not just a minor rounding error. The theoretical prediction is strictly larger than the actual measurement by a factor of 10 to the power of 120. That is a 1 followed by 120 zeros. To put that completely incomprehensible number into perspective, there are only about 10 to the power of 80 atoms in the entire observable universe. If you took every single atom in every star and multiplied that massive number by 1 trillion, and then by 1 trillion again, you would still not even be close to matching the sheer scale of this mathematical error. This staggering, incomprehensible mathematical discrepancy is universally known as the cosmological constant problem. It is widely considered by theoretical physicists to be the absolute worst theoretical prediction in the entire history of modern science. The actual energy of the vacuum is catastrophically smaller than the strict laws of physics say it should be. It makes absolutely no mathematical sense. However, this massive failure in our equations leads directly to a terrifying, existential realization. If the quantum mathematics had been perfectly correct, and the vacuum energy was exactly as powerful as predicted, the universe would have been instantly ripped apart in its very first fractions of a second. Space would have expanded so violently, and the cosmic voids would have pushed outwards so aggressively that not a single physical atom could have ever formed. 2 hydrogen atoms would never have been able to find each other. There would be no burning stars, no massive galaxies, no heavy carbon, and absolutely no humans. The universe would be a completely dead, rapidly stretching abyss of pure microscopic radiation. We understand a fundamental, mathematical difference in how these two colossal forces operate over the grand sweep of cosmic time. Gravity is a localized force of attraction between physical masses, and its overall strength rapidly, exponentially weakens as the distance between those interacting masses increases. As the universe naturally expands following the explosive momentum of the Big Bang, the physical distance between the massive galactic superclusters grows larger and larger every single day. Consequently, the gravitational pull desperately trying to hold them all together becomes weaker and weaker. It is exactly like a stretched rubber band that is slowly losing its structural integrity under too much tension. Dark energy, however, operates on an entirely different, almost paradoxical set of physical rules. It is not tied to mass or matter, it is a fundamental intrinsic property of the empty vacuum of space itself. It is the raw energy of nothingness. This means that as the universe expands and creates more empty space, the total amount of dark energy in the universe actively, continuously increases. This creates a terrifying, self-destructive and entirely unstoppable feedback loop. As dark energy aggressively pushes the galaxies apart, it naturally creates more empty space between them. That newly created empty space contains even more dark energy. That additional dark energy pushes the galaxies apart even faster, which creates even more empty space, generating even more dark energy in a rapidly escalating cycle of cosmic destruction. Because of this runaway feedback loop, the physical expansion of the universe is not just continuing, it is aggressively, violently accelerating. This definitively answers the dark, lingering question of the universe's ultimate fate that we explored earlier. Gravity is currently experiencing a catastrophic, irreversible runaway syndrome. It is permanently losing its desperate grip on the large-scale structure of reality. Over the next 100 billion years, the repulsive force of dark energy will completely, undeniably overpower the gravitational bindings of the heavy dark matter halos. The destruction will happen in violent, staggering stages over incomprehensible timescales. First, the massive glowing superclusters will be violently torn apart, their fragile cosmic filaments snapping like dry twigs in a massive hurricane. Then, the individual galaxies themselves will be violently stripped of their outer stars, scattered helplessly into the rapidly expanding dark like dust in the wind. Eventually, even the solar systems will be torn apart, isolating every single planet. The cosmic voids will continue to swell, aggressively consuming everything in their path. The ultimate final power of dark energy is absolute, permanent, unyielding isolation. The universe will inevitably end in a freezing, stretching phenomenon known as the heat death, where every single subatomic particle is pushed so far apart that no two atoms will ever interact again. The terrifying voids will eventually win, and they will win permanently, leaving behind a cold, dead, endless expanse. To fully comprehend the sheer, staggering violence of this cosmic endgame, we have to look closely at the ultimate speed limit of reality, the speed of light paradox. According to the strict, unbreakable laws of physics, absolutely nothing can travel through space faster than the speed of light. It is the hard mathematical speed limit of the universe, dictating the flow of time and information. But there is a massive, horrifying loophole in Albert Einstein's equations of general relativity. While no physical object with mass can travel through space faster than light, space itself has no such speed limit. Space is not an object, it is the stage upon which objects exist, and the stage is expanding at a terrifying rate. Dark energy is stretching the underlying invisible fabric of the universe so aggressively that the distant galaxies are physically receding from us at velocities far exceeding the speed of light. The massive cosmic voids are expanding faster than the fundamental speed limit of physical reality. This creates a horrifying optical illusion. This means that the universe is aggressively, actively hiding itself from us. As the empty space between us and a distant galaxy expands faster than a photon of light can travel across it, the light from that galaxy will never, ever reach our telescopes, no matter how long we wait. The universe is systematically deleting its own history. The breathtaking night sky is actively being erased by the aggressive, relentless expansion of nothingness. Every single day, billions of ancient stars silently slip past the cosmic horizon, forever lost to the expanding dark. The observable universe is rapidly shrinking, leaving us completely stranded, and this brings us to the ultimate epic enlightenment. This is the profound final answer to the grand paradox we established at the very beginning of this journey. Why is the universe so overwhelmingly, terrifyingly empty? Because that massive, isolating emptiness is the exact mechanical reason you are alive to witness it. If dark energy wasn't aggressively, relentlessly expanding the universe, the heavy, suffocating grip of dark matter would have crushed everything into a singular dead black hole billions of years ago. But because the colossal voids exist, and because the empty vacuum of space is actively, forcefully pushing the universe apart at exactly the right speed, the solid matter was given just enough crucial breathing room. It was given the precise physical space and the necessary billions of years of deep time required to form massive, swirling galaxies. This immense time allowed the universe to actively ignite burning stars, slowly construct rocky planets, and eventually spark the incredibly fragile flame of biological intelligent life. The staggering, overwhelming emptiness of the cosmos is not a mistake, and it is not a tragic waste of space. It is the fundamental structural scaffolding of existence itself. We look up at the night sky, and we often feel a profound, crushing sense of isolation when we realize that 95% of reality is an invisible, empty void. We naturally feel small and insignificant, but that exact same void is precisely what kept us from being violently crushed out of existence. The exact same repulsive force that will eventually kill the entire universe and tear it apart is the exact same force that allowed it to live in the first place. This is the ultimate, breathtaking paradox of human existence, the final resolution to the terrifying question of our cosmic isolation. The terrifying emptiness is not your enemy. It is your creator, your protector, and eventually your inevitable destroyer. We were born directly from the chaotic mechanics of the empty voids, and over the course of trillions of years, we will be slowly, inevitably returned to them, fading back into the absolute dark. The universe is a breathtaking masterclass in perfectly balanced destruction and creation. You're not just a passive observer in this grand cosmic play. You exist as a temporary glowing spark in the brief beautiful transition period between a violently fiery birth and an endlessly freezing, rapidly expanding death. You are the universe briefly waking up to look at itself, sustained entirely by the massive empty space that surrounds you on all sides. Your existence is a mathematical miracle born from the void, and this is exactly where the logic of our small, comfortable world finally falls apart, plunging us into the staggering reality of the macro scale. That inescapable conclusion only makes sense once you understand the true, incomprehensible scale of the universe. The human brain is a remarkable biological computer, but it was specifically evolved over millions of years to solve highly localized terrestrial problems. So we evolved to track the movement of predators across the African savanna, to calculate the trajectory of a thrown spear, and to estimate the distance to the nearest water source. Our neurology is perfectly calibrated for distances ranging from a few millimeters to a few miles. Due to this biological limitation, when we hear terms like 93 billion light years, or hundreds of millions of years, our brains simply shut down. We cannot process these numbers. They become abstract, meaningless mathematical noise. To truly comprehend the horrifying isolation of our cosmic cage, and to feel the absolute crushing weight of the emptiness that surrounds us, we have to forcibly bypass our biological limitations. We have to violently scale the universe down to something we can comfortably hold in our hands. Let's start with the sheer, incomprehensible volume of the emptiness. Imagine that an infinitely powerful, magical hand reached down from the heavens, grabbed the entire 93 billion light-year expanse of the observable universe, and squeezed it down until it was exactly the size of planet Earth. In this dramatically scaled-down model, the observable universe is a sphere roughly 8,000 miles wide. Now ask yourself, inside this Earth-sized universe, how much physical space would all the solid matter physically take up? Imagine gathering every single one of the 2 trillion galaxies, every burning star and every massive black hole. Now, violently compress all of that solid matter together into a single incredibly dense clump. Exactly how large would it be? In an Earth-sized universe, all the physical matter in existence would easily fit into a single solitary grain of sand. Just one grain of sand. That is the true, horrifying physical reality of the cosmic energy budget. Everything else, the entire rest of the Earth-sized sphere from the core to the crust, stretching across every ocean and every continent, would be completely, utterly empty space. It would be a dark, freezing vacuum, heavily dominated by the pulling force of dark matter and aggressively pushed apart by the repulsive pressure of dark energy. When you look up at the night sky and marvel at the breathtaking beauty of the Milky Way, you are simply staring at a microscopic imperfection, a tiny, glittering flaw suspended in a boundless ocean of absolute nothingness. But even that single grain of sand is not clumped together. It is aggressively shattered, violently pulverized, and scattered across the darkness. To understand the sheer, terrifying isolation of the individual stars within our own galaxy, we need another scale. Let's zoom in and look at our own local neighborhood. Imagine that we shrink our massive burning sun down until it too is exactly the size of a single grain of sand. We take this tiny glowing grain of sand and we place it right in the middle of a vast empty beach. Where is the nearest star? Proxima Centauri is our closest stellar neighbor. In this highly scaled down model where the sun is a grain of sand, Proxima Centauri is not sitting right next to it. It is not a few feet away. It is not even on the same beach. In this scale, the very nearest grain of sand is sitting completely alone, isolated in the dark, roughly 30 to 40 kilometers away. And that is our absolute closest neighbor in the entire cosmos. If you want to reach the next star after that, you have to travel another 30 kilometers in a different direction to find one more lonely grain of sand. The stars are not a bustling, crowded community. They are impossibly isolated islands of burning gas, separated by staggering, insurmountable oceans of cold, empty space. Even within the densest parts of a galaxy, the emptiness is absolute and overwhelmingly dominant. This terrifying isolation becomes even more apparent when we look at humanity's greatest technological achievements. We are incredibly proud of our space exploration. In 1977, the National Aeronautics and Space Administration launched the Voyager 1 spacecraft. It is the fastest, farthest-reaching machine ever built by the human race. It is currently hurtling through the freezing dark of interstellar space at a staggering speed of roughly 17 kilometers every single second. To a human being, that speed is almost incomprehensible. It is faster than a fired bullet. But in the grand, sweeping arena of the cosmos, Voyager 1 is a cruel joke. It is practically standing still. Imagine pointing Voyager 1 directly toward the very edge of the local void, the massive empty region of space sitting just outside our galactic neighborhood. Traveling at 17 kilometers per second, it would take Voyager hundreds of millions of years just to reach the absolute edge of that void. It would take tens of billions of years to physically cross it. If an immortal observer were to stand back and watch the grand mechanics of the universe unfold, human spaceflight would look entirely motionless. On a cosmic scale, Voyager 1 is not a fast-moving spacecraft, it is a frozen, stationary metal statue, permanently suspended in the dark, entirely incapable of escaping its immediate local gravity well. We are permanently trapped on our tiny grain of sand, but the terrifying scale of the universe is not just about physical distance. It is also about the aggressive, relentless passage of time and the bizarre way that light interacts with the emptiness. The speed of light is the absolute speed limit of the universe, clocking in at roughly 300,000 kilometers per second. It is the fastest anything can possibly move. But even light, the ultimate cosmic messenger, is hopelessly outmatched by the sheer scale of the massive voids. Consider the staggering 330 million light-year expanse of the Boötes Void. To cross this monstrous region of nothingness, a photon of light must travel at absolute top speed without stopping for 330 million years. Let's put that immense time frame into biological perspective. Imagine a single photon of light entering the far edge of the Boötes Void, beginning its long dark journey toward Earth. When that photon first crossed the threshold into the dark, the Earth was a radically different planet. The continents were fused together into the massive supercontinent of Pangaea. The very first primitive dinosaurs were just beginning to evolve. There were no flowers, no birds, and certainly no mammals. As the photon traveled through the freezing, empty heart of the void, tens of millions of years slowly ticked by. Down on Earth, entire species rose to dominance, ruled the planet for millions of years, and then violently went extinct. The massive asteroid hit the Yucatan Peninsula, wiping out the dinosaurs and plunging the world into a deep nuclear winter. The continents violently drifted apart, crashing into each other to form the Himalayas and the massive Alps. As the photon finally approached the near edge of the void, nearing the end of its journey, a strange bipedal ape climbed down from the trees in the African savanna. As the photon crossed the final stretch of intergalactic space, that ape learned how to control fire, invented the wheel, and built the Great Pyramids of Giza. It fought 2 massive world wars, split the atom, and eventually built a highly complex optical telescope. Finally, after 330 million years of silent, uninterrupted travel through the absolute darkest, emptiest region of the universe, that photon struck the digital sensor of that telescope, registering as a tiny, faint blip of light. The emptiness of the universe is so vast that the entire evolutionary history of intelligent life on Earth is just a brief, flashing moment. The timeline from the rise of the dinosaurs to the invention of the internet is nothing compared to the time it takes light to cross a single cosmic pothole. We are an incredibly fleeting phenomenon. Consider the absolute opposite end of the timeline. The violent birth of the universe was equally incomprehensible. During cosmic inflation, in the first fractions of a second following the Big Bang, the universe expanded from something vastly smaller than a single subatomic particle to a staggering macroscopic volume. The sheer violence of this initial expansion defies all human logic. In a fraction of a microsecond, the foundational structure of the 93 billion light-year map we see today was permanently drawn, freezing the microscopic quantum fluctuations into the macroscopic scaffolding of the cosmic voids. The universe went from a microscopic speck to a colossal stretching canvas faster than a human neuron could even fire. Time and space were stretched and violently distorted beyond all recognition, and yet this vast emptiness is not a uniform, peaceful void. It is a landscape of violent, extreme contrasts. The density of the universe swings wildly from one extreme to the exact opposite, creating a heavily localized, incredibly hostile environment. Deep inside the Boötes Void, the average density of matter is so staggeringly low that it is almost impossible to comprehend. Take the most advanced, highly sophisticated vacuum chamber ever built in a laboratory on Earth. This machine is designed to violently suck out every possible atom of air to create a perfect void. However, that artificial vacuum would still be packed with billions of times more matter than the natural vacuum found inside a cosmic void. The voids are the closest thing to true, mathematical nothingness that exists in physical reality. But if you look at the exact opposite end of the spectrum, you find structures of incomprehensible violence and density. Consider the crushing, terrifying weight of a neutron star, the dead, collapsed core of a massive supernova. A neutron star is fundamentally a massive city-sized atomic nucleus. Its matter is packed so tightly that a single teaspoon of it would weigh trillions of tons on Earth. To truly grasp this density, imagine trying to squeeze the entire mass of Mount Everest into a sugar cube. That is the physical reality of a neutron star. The universe is a place of violent, schizophrenic extremes. It is a place where a tiny teaspoon of crushed matter can completely outweigh an entire terrestrial mountain range. Simultaneously, it harbors regions of empty space so impossibly vast and so incredibly sparse that they make our absolute best laboratory vacuums look like a crowded, heavily populated metropolis. This brings us to the final, and perhaps the most deeply melancholic shock of all, the true, overarching timeline of the cosmos. The universe we live in right now feels permanent and stable. It feels like the night sky has always been filled with burning stars and always will be. Astrophysicists call our current epoch the stelliferous era, or the era of stars. This is the brief, beautiful window of time when the universe is actively forming new stars, when galaxies are colliding and merging, and when biological life has the warmth and energy required to evolve and thrive. But the stelliferous era is not permanent. It is a temporary, highly localized anomaly. Eventually, the aggressive, repulsive force of dark energy will forcefully push the galaxies so far apart that the cosmic supply chain of hydrogen gas will be permanently severed. The star-forming factories will violently shut down. The last of the red dwarf stars will slowly, quietly burn through their remaining fuel and fade into dead, freezing black dwarfs. The universe will enter the degenerate era and eventually the black hole era. After trillions upon trillions of years, even the supermassive black holes will begin to slowly evaporate due to Hawking radiation, bleeding their mass away into the expanding dark. The final, mathematical endgame of the universe is a state of maximum entropy known as the heat death. In this unimaginable future, the universe will be nothing more than a rapidly expanding, infinitely freezing soup of perfectly isolated photons and subatomic particles. The temperature will drop to absolute zero. The empty voids will have completely and utterly won. To truly understand how insignificant our brief moment in the sun physically is, we must compress this entire, terrifying cosmic timeline into a single calendar year. Imagine that the absolute beginning of the universe, the explosive Big Bang, occurs precisely at midnight on January 1st, and the absolute end of the universe, the final, freezing heat death, occurs precisely at midnight on December the 31st. In this cosmic calendar, how long does our beautiful, vibrant, star-filled universe last? How long do the glowing galaxies, the burning suns, and the fragile biological life forms physically exist? If the entire lifespan of the universe is exactly one calendar year, the stelliferous era, the era of light, warmth, and life, does not last for months. It does not last for weeks or days or even hours. If the entire timeline of the universe is 1 year, the era of burning stars is completely over within the very first millionth of a single second on January 1st. The light goes out almost immediately. The stars are a momentary microscopic spark in the dark, and for the entire rest of the year, for the remaining 364 days, 23 hours, 59 minutes, and 59.999 seconds, the universe is completely dead, rapidly expanding, utterly pitch-black, freezing, empty void. We are living in a temporary, incredibly lucky mathematical era. The universe was not built for us. It is a vast, hostile, expanding machine of nothingness, and we are just a fleeting spark waiting to be swallowed by the dark. But how do we actually know all of this? So, the grand, terrifying paradox of the cosmos that we just explored, the accelerating expansion, the massive voids, the aggressive push of dark energy, is not just an elegant philosophical theory. It is a hard mathematical reality. It is a reality built on decades of relentless, obsessive human observation, driven by a deeply ingrained psychological need to understand our place in the void. For centuries, our species has refused to accept the limitations of our own biology. We are a species trapped on a tiny rock, yet we have continuously built larger mirrors, more sensitive digital sensors, and increasingly complex orbital observatories to desperately peer into the absolute pitch-black abyss. But we did not simply guess the shape, the mass, and the terrifying mechanics of the dark. We painstakingly, meticulously measured them using the most sophisticated engineering ever conceived. To truly grasp the magnitude of this cosmic architecture, we must look at the mechanical heart of the dark. We must look at the actual machines, the orbital satellites, and the subterranean detectors that mathematically mapped our isolation. In 1995, humanity took one of the greatest, most audacious scientific gambles in modern astronomical history. The Hubble Space Telescope, orbiting high above the distorting effects of Earth's atmosphere, was aimed at a tiny, seemingly insignificant patch of sky near the constellation Ursa Major. To the naked human eye, and to every powerful ground-based telescope in existence at the time, this specific region of space was completely, utterly empty. It was a pitch-black void, roughly the size of a pinhead held at arm's length against the night sky. Many brilliant astronomers furiously argued that this highly controversial experiment was a tragic, inexcusable waste of incredibly valuable orbital telescope time. They firmly believed that pointing our most advanced, expensive optical instrument at a patch of absolute nothingness for 10 consecutive days would yield absolutely nothing but dark, useless pixels. But the telescope stared into the dark, aggressively soaking up every single stray photon it could possibly catch over hundreds of hours of exposure. When the final, deeply processed images were eventually downloaded and sent back to Earth, they completely shattered our fundamental understanding of reality. That tiny, pitch-black pinhead of seemingly empty space was not empty at all. The resulting Hubble Deep Field image revealed over 3,000 distinct ancient galaxies, burning brightly in the deep background of the cosmos. This single, staggering photograph fundamentally proved that the universe was infinitely larger, significantly older, and far more heavily populated with massive galactic structures than anyone had ever dared to imagine. It definitively proved that even in the absolute darkest, emptiest-looking corners of the night sky, there are billions of islands of light, forever isolated by the expanding voids. But humanity's obsessive need to see deeper into the dark and further back in time did not stop there. Decades later, we launched the James Webb Space Telescope, a massive, gold-plated engineering marvel designed to see the universe not in standard visible light, but in deep infrared. By the years 2025 and 2026, the unprecedented data streaming back from Webb began to violently disrupt the established textbook models of cosmic evolution. Webb possessed the capability to look back to the very dawn of time, peering through dense clouds of cosmic dust to see the universe just a few 100 million years after the initial Big Bang, and it found something that theoretically should not exist. It discovered excessively massive, highly structured, fully mature spiral galaxies sitting in the extremely early universe. According to all our standard cosmological models, there simply had not been enough time for normal matter to clump together and form such complex, massive structures. The only possible explanation was that the invisible scaffolding of dark matter had operated with terrifying efficiency, aggressively pulling gas and dust together far faster and far earlier than anyone had mathematically calculated. Webb did not just show us the early universe, it fundamentally broke our current understanding of how quickly the dark matter halos constructed the very first galactic foundations, plunging astrophysics into a brand new crisis. While Webb looked at the first ancient galaxies, the Planck satellite was specifically designed to look even further back, to the absolute oldest light in existence, the cosmic microwave background radiation. This is the fading, glowing, radioactive echo of the Big Bang itself, permeating every single inch of the cosmos. As Planck meticulously mapped the incredibly slight temperature variations of this ancient microwave radiation across the entire sky, it discovered a massive, glaring anomaly. There was a gigantic, abnormally cold patch in the southern sky, famously known in cosmology as the cold spot. When astronomers cross-referenced this massive cold spot with deep space galaxy surveys, they made a terrifying connection. The cold spot perfectly aligned with the Eridanus supervoid, one of the most massive empty regions of nothingness ever discovered in human history. As the ancient photons from the Big Bang traveled through this colossal void on their way to Earth, they were actively losing energy. Because dark energy is constantly, relentlessly stretching the fabric of the void, the photons had to fight a steep uphill gravitational battle to escape the rapidly expanding region, bleeding off energy and cooling down in the process. This specific phenomenon, known as the integrated Sachs-Wolf effect, provided some of the most elegant, undeniable proof that dark energy is actively tearing the universe apart in real time. But measuring the deep, distant universe is only half the battle in cosmology. How do we exactly map the invisible dark matter that is lurking right here in our own cosmic backyard? We cannot directly see the massive dark matter halo that heavily surrounds the Milky Way because it emits absolutely no light, absorbs no heat, and produces no detectable radiation. To solve this frustrating local mystery, the European Space Agency launched the highly advanced Gaia Observatory. Gaia employed an incredibly brilliant indirect strategy to map the dark. Instead of trying to see the invisible dark matter directly, Gaia meticulously tracked the three-dimensional speeds, the complex orbital trajectories, and the precise accelerations of billions of individual visible stars within our home galaxy over several years. By accurately mapping exactly how the visible stars were moving over time, astronomers could clearly see the gravitational anomalies. They could see millions of stars being aggressively pulled and accelerated by massive, entirely unseen forces. By carefully tracking the invisible gravitational strings pulling on the visible matter, Gaia successfully mapped the exact shape and the dense distribution of the invisible dark matter halo enveloping our entire galaxy. We finally saw the invisible, simply by watching how it manipulated the light. Yet, despite all of our massive orbital telescopes and our incredibly precise deep space mapping, the fundamental physical nature of the dark matter particle itself remains a maddening, highly elusive ghost. To directly catch this ghost, scientists had to completely look away from the stars and go deep underground. In a massive, heavily shielded cavern situated a full mile beneath the surface of South Dakota, researchers constructed the highly ambitious LUX-ZEPLIN experiment. This is an enormous, 7-ton tank of highly purified liquid xenon, buried deep inside the Earth to aggressively protect it from all interfering cosmic radiation. The ultimate goal of this massive subterranean laboratory is to directly detect a WIMP, a weakly interacting massive particle, as it completely ignores the solid rock of the Earth and violently passes through the liquid xenon. In August of 2024, the LUX-ZEPLIN team officially released their most anticipated data yet. The underground detector had successfully drawn the absolute strictest, most aggressively narrow limits on the mass and interaction probability of dark matter in human history. It pushed our terrestrial technological capability to its absolute breaking point. And yet, despite the unprecedented, extreme sensitivity of the 7-ton detector, not a single dark matter particle was definitively found. The invisible mass that holds the entire universe together continues to slip through our fingers, perfectly evading our most advanced terrestrial traps. But even with all this profound knowledge, the terrifying truth is that we have barely scratched the surface of the dark. But how does this delicate mathematical balance, this cosmic tipping point, actually work? Let's take it apart. The invisible mass that holds the entire universe together continues to slip through our fingers, perfectly evading our most advanced terrestrial traps. We have built a formidable, highly sophisticated arsenal of orbital telescopes and subterranean detectors, yet the cosmos stubbornly refuses to surrender its deepest, most fundamental secrets. Today, leading astrophysicists and brilliant theoretical cosmologists are locked in a desperate, highly frustrating intellectual war against 3 massive, totally unresolved mysteries. These are the critical open questions that continuously challenge our understanding of reality and keep the brightest minds on Earth awake at night, furiously calculating in the dark. The first profound question is perhaps the most obvious, yet the most frustrating. What exactly is the true physical nature of dark matter? The confirmed reality is that a massive invisible gravitational force is holding our rapidly spinning galaxies together and forcefully bending ancient light through a process called gravitational lensing. The mainstream scientific hypothesis strongly suggests that this invisible scaffolding is made of undiscovered exotic particles, like weakly interacting massive particles, or WIMPs, or highly theoretical, incredibly light wave-like particles called axions. Massive, multi-billion-dollar laboratories, like the Large Hadron Collider operated by CERN deep beneath the European continent and the subterranean LUX-ZEPLIN detector in America, are furiously working to physically capture these elusive particles by violently smashing atoms together or monitoring incredibly still vats of liquid xenon. However, there is a highly controversial, radically different theory known as modified Newtonian dynamics, or MOND. This deeply disruptive theory suggests that dark matter might not physically exist as a particle at all. Instead, it proposes that our fundamental, deeply trusted mathematical laws of gravity are simply incorrect when they are applied to the incredibly vast distances and extremely low accelerations found in deep intergalactic space. If a MOND is eventually proven correct, the entire foundation of modern astrophysics will have to be completely, painstakingly rewritten from scratch. The second terrifying question focuses on the engine of our ultimate destruction. Is dark energy a permanent, completely static force, or is it dynamic, unstable, and changing over the vast sweep of cosmic time? We absolutely know that the universe is aggressively expanding, and that this expansion is accelerating. The standard, comfortable assumption for decades has been that dark energy is a fixed, unchanging property of empty space itself, a cosmological constant famously represented by the Greek letter lambda. But highly recent observational data has plunged the field of cosmology into a state of absolute panic. Massive, highly advanced mapping projects, like the Dark Energy Spectroscopic Instrument, or DESI, and the European Space Telescope Euclid, have meticulously analysed the 3-dimensional distribution of hundreds of millions of galaxies. The shocking 2024 data suggest a terrifying, highly unsettling possibility. Dark energy might not be mathematically constant. It might be a dynamic, shifting, highly volatile field, often referred to in theoretical physics as quintessence. This means that the repulsive force actively tearing the universe apart could potentially weaken in the deep future, or it could aggressively strengthen, radically altering the ultimate fate of reality itself. Which brings us directly to the third and most deeply existential question of all: how will the universe definitively end? Because the universe is currently expanding and cooling down, the standard, widely mathematically accepted fate is the freezing, highly isolating heat death we explored earlier. But if dark energy is indeed a dynamic, highly unstable force as the new data suggests, the apocalyptic scenarios become significantly more violent and unpredictable. If the acceleration of dark energy suddenly spikes and spirals completely out of physical control, the universe could suffer a catastrophic event known as the Big Rip. In this terrifying, highly extreme scenario, the expansion of the spatial vacuum becomes so insanely powerful that it completely overcomes the strong nuclear force, violently tearing apart individual atoms and obliterating all physical matter entirely. Alternatively, advanced theoretical physics suggests that over unimaginable trillions of years, the very building blocks of reality, the protons themselves, might slowly undergo radioactive decay, completely dissolving solid matter into a thin mist of nothingness. We are living inside a highly unstable, deeply unpredictable cosmic machine, and astrophysicists do not definitively know how the final gears will turn. And this is exactly where the logic of our small, comfortable world finally falls apart. When we look up at the night sky, we're not just looking at a peaceful canopy of burning stars. We are looking at a fragile temporary illusion, perfectly suspended over a massive, violently shifting mathematical equation that we do not fully understand. We exist in a state of profound, highly improbable luck. This staggering luck is not just about the incredibly fragile biological chemistry that miraculously allows us to breathe, think, and build massive optical telescopes. It is fundamentally about the specific, incredibly narrow window of cosmic time in which our species happens to be alive. We are living in a golden era of observation, a fleeting moment where the sweeping architecture of the universe, the rapidly expanding voids, the massive superclusters, and the fading echoes of the explosive Big Bang is still physically visible. But this observational privilege will not last. The universe is actively erasing its own deep history, because dark energy is relentlessly accelerating the physical expansion of empty space. The visible cosmic horizon is slowly but definitively closing in around us. Trillions of years from now, deep in the fading twilight of the stelliferous era, new biological life forms and highly advanced civilizations will inevitably emerge on distant rocky planets scattered across the dark. But when the brilliant, highly ambitious astronomers of that deeply isolated future build their own massive telescopes and point them toward the deep heavens, they will see absolutely nothing beyond the immediate borders of their own local galaxy. By that distant epoch, the terrifying acceleration of dark energy will have forcefully pushed every single neighboring galaxy so incredibly far away and so unimaginably fast that their light will be permanently severed, never to reach those future observers again. Furthermore, the cosmic microwave background radiation, the glowing fingerprint of the Big Bang itself, will have stretched and cooled so drastically that it will be completely undetectable. The physical universe will have violently wiped the cosmic slate completely clean, burying its own origins forever. Those future civilizations will have absolutely no physical or observational evidence that the universe is aggressively expanding. They will have absolutely no concept of the Big Bang. They will possess no historical record of the colossal cosmic web, the massive superclusters, or the violent interplay between dark matter and dark energy. When they look up at the night sky, their perceived universe will consist entirely of their own solitary galaxy, completely surrounded by an endless pitch-black ocean of absolute nothingness. They will falsely, tragically believe that they are completely alone in a static, unchanging, and exceptionally small universe. We, however, have the breathtaking, highly unique privilege of witnessing the grand mechanics of the cosmos while the stage lights are still fully turned on. We can still see the terrifying scale of the expanding voids and the massive gravitational scaffolding that physically holds reality together. And in seeing it, we finally, truly understand the ultimate profound truth of our own deeply unlikely existence. The staggering emptiness of the universe is not a tragic, meaningless waste of space, nor is it a hostile void designed to crush our spirits. The massive, swelling cosmic voids are the essential physical breathing room of reality itself. They are the deeply necessary mathematical counterbalance to the overwhelming, crushing weight of dark matter. If the universe had been even slightly more dense, gravity would have violently crushed everything back into a singular, dead black hole billions of years ago. If it had been slightly more empty, matter would have been swept away into the dark and it would have never clumped together to form the first burning stars. The vast emptiness is the highly precise physical framework that allowed the swirling galaxies to form, the stars to ignite, and the heavy elements in your blood to be forged. You now know what the cosmos really is, and why its terrifying emptiness is the exact reason you exist. We were born not in spite of the dark, but directly because of it. The massive voids gave us the space and time required to simply be. When we look up into the overwhelming blackness of the night sky, we should not feel a crushing sense of isolation or insignificance. We should feel a profound, sweeping sense of melancholic gratitude for the empty dark that safely cradled our creation. The universe is overwhelmingly, terrifyingly empty, yet that exact emptiness is the physical reason you're alive today. How does that realization make you feel? Does it make you feel small or incredibly lucky to exist? Let me know in the comments below. The cosmos is packed with terrifying paradoxes and dark mysteries. If you want to continue exploring the absolute limits of reality with us, make sure to hit that subscribe button. Don't get lost in the dark alone. In our next video, we go deep underground. CERN scientists have just revealed a highly classified, absolutely terrifying truth about the very fabric of physical reality, and the most disturbing part is that almost no one knows about it yet. You will not want to miss it. As always, stay curious. Until next time, keep questioning.